Hi, I'm a student learning chemistry, and today I'll be taking two exams, Chemistry A and Chemistry B. After Chemistry A, I'll be doing a Google study for about an hour. Then I'll take the Chemistry B to see if Google study has helped or not. Okay. Use this diagram to answer the following 7 questions. We have X, Y, Z, some other alphabets, some branches with no symbols, and a triangle here. There are blank number of carbon atoms in the parent chain, and it is called blank. One, two, three, four, five, six, 7. So that's not it. Well, this one is pretty straightforward. 5 and pentagon makes sense, so I'll select this one. Numbering of this module will begin at carbon what? So numbering of this module, so I assume the 5 pentagon. Let's see. This one would make sense to be the first one, or one of the edges at least. I would say it would make more sense to go from left to right, so that's kind of like a 5. So numbering of this module will begin at carbon A. Use this information along with the previous diagram to answer the following 5 questions. There are branches at carbon X, Y, and Z. The branches at carbon X are called what? So there are branches at X, Y, and Z. I see X, Y, and Z have branches. Yeah, so it makes more sense now just from the exam. But X has branches, Y has branches, and Z has branches. So it would be 1, 2, 3, 4, 5 with 1, 2, 3 branches. And so we're looking at what is X is called, the triangle one. And another one sticking out. So I don't know what they're called. I'm not an expert at chemistry. I'm trying to see if there's any hint here. So I assume over here it says branches and it says is or are. So I assume there is 2. And that has to be either this one or this one. Propyl, cyclopropyl. I wonder which one it is. Okay, so we'll do some more study on this one. There is a type of branch that is common between carbon X and Z. What is it called? There's a branch that is common between X and Z. X and Z, which is Y, and I guess it's this one. There is a type of branch that is common between, oh, I see. So I guess this branch is common. The one off one exists in these two, in the X and Z, but doesn't exist in, well, I guess it does exist in Y too. No, that only goes one straight, so this one has a bend. These are just one single straight line. That would be called, I'm not sure, we'll need to do some research on that one. Which carbon is able to make another bond? So I would say Y. What is the UIPAC name of this molecule? Not sure. The addition of a methyl group onto carbon, what would cause it change only to the name of the parent chain? The addition of a methyl group onto carbon would cause a change only to the name of the parent chain. Maybe this one. Is that the right, symbol? Next. Which of the following molecules is not an organic molecule? Molecules is not an organic molecule. Tetra, tert, benzene, hydro, tert bauxite. How many valence electrons are present in butane? How many valence? 24. That's the lowest one. 24. 2 dozen. 28. How many valence? Let's go with 24. Same number of electrons as the butane has valence electrons. So which element has the same number of electrons as butane? Chromium. Which of the following functional groups is most likely to emit a pleasant sweet smell? Interesting. To emit a pleasant sweet smell? Rukush. I'm not sure what these are, but we'll do more research on them. Can you answer to the previous question? Participate in hydrogen bonding? Pleasant sweet smell. Yes, because yes, because it is emitting a chemical. What? That's what I said. Okay. Which molecule will have the highest bonding point, boiling point? CH4. Let's go with CH4. How many hydrogen atoms does an alkene with n carbon atoms have? Hydrogen atom does an alkene. How many hydrogen atoms does an alkene with n carbon atom have? Not sure. I'll say 2n. Okay. Use this information to answer the following 5 questions. So that's the molecule names, boiling point. I wish I could go back. I remember there was the highest boiling point, which that would be decane. Interesting. Which molecule have London dispersion forces? I wonder what London dispersion forces mean. I think these two are the lowest under 100, so maybe just this one, because the difference is like more than 10. The difference between these two are 50, so I'll just select both of them. Assume each substance is a liquid at room temperature. Which of these molecules can mix with water? It's about the density of the chemical. I'm not sure. I'll go ethanol only, heptane only. Why can they mix with water? Room temperature. I wonder what room temperature. Maybe closer to 78. That's still pretty hot, I would say. It has similar boiling points. Maybe that has something to do with it. Despite that, decane does not have permanent dipole. Its boiling point is much higher than ethanoic acid. Why? Interesting. Oxygen decreases boiling point. Oh, I'm not sure which one it is. Decane contains the most carbon atom. Probably Y. Where would you expect methanol to place in this list? Methanol, ethanol, like right in the middle. Yeah. Use this diagram to answer the following 4 questions. The additional of methyl group to which carbon would not produce a molecule with side chain? A side chain. I wonder what that means. Would not produce molecule. All of the above would produce a molecule with a side chain, because there is no difference. Oh, there is a difference. A doesn't have anything on its sides, but these two, they have each other on its side. So I'll select the top one. To which carbon would produce the same molecule. To carbon B and Y. How many valence electrons are present in this molecule? 3. What is the maximum number of? 2, because 1 and 2, I'm not sure. The electrons is a benzene molecule are not fixed on one atom. They are blank. Not sure. An acidic flower compound has been discovered. It is naturally dissolved in an organic solvent. That is, it is non-polar. It does not have any natural odor or color. In the lab, you are presented with 5 vials that contain the flavor compound. How will you attempt to detect its presence? I would try to add water. An organic compound will rapidly dissolve in water. Add orange dye. An artificial orange dye will absorb into an acidic. Interesting. So these are some chemical reactions that are showing to prove the concept. Nice, this one is cool. It neutralizes the solution. Let's go with titrated using NaOH. NaOH will neutralize the solution. View score. Wow, 7 out of 25. Let's do some research on some of them. Wow, so this one was 6-hexane, because there is 1, 2, 3, 1, 2, 3, 4, 5, and 6. Let's look it up, see what we get. So we get a little AI overview. The number of carbon atoms in the longest continuous carbon chain of an organic molecule determines its base name, often called the parent chain, the root name. So I guess it is the longest chain. Like it would be 1, 2, 3, 4, 5, and 6. I see, so all of it combined. I see. Let's see if we find any websites. Lumen Learning. Nice, so it says not all hydrogen bonds are straight chains. Many hydrogen have branches of C atoms called branches hydrocarbons. These are alkanes or isomers of straight chains. Alkanes having the same number of C atoms. Cool. Let's check another one. Chemistry. This one is nice too. Tracing your family tree can both be fun and exciting. In order to do this correctly, okay, so it's telling us branched alkanes, butane, beginning with butanes. Interesting. So this one was correct. It starts from A2. And then this one was, so I did say it's methyl and something, but it was the other one, cyclopropyl, because it's cycling. Nice. Which carbon is another to make another bond? Is this one? So what is the IUPAC name of this module? So maybe we could look this up, see if we could figure out ours. It says 2-cycle 3-ethyl and 4 trimethylhexanes. So I guess you get the name based on the shape. So we need to know how to read the shapes. The AI overview, IUPAC stands for the International Union of Pure and Applied Chemistry. It is a non-governmental organization that acts as a world authority on chemistry. Let's find the website. The chemistry library text was nice. Okay, overview of IUPAC system for naming organic compounds. Wow, so there's a very nice table and a detailed lines here. Let's see if we could figure it out. The International Union of Pure and Applied Chemistry has established its rules. Recognize and prioritize the functional groups present. Identify the number of longest continuous carbon chain. So that's what we were doing. Cite the substituents branch, so cite the branches. Spatial orientation, position of ID, suffix, highest ranking of group, multiplied bond, so whatever times n, parent chain. This is very cool actually. Still a little complicated. But it did make sense. And ours is called 2-cyclopropyl ethyl 3-ethyl. So if we go over here, so 2-cyclopropyl 3-ethyl, then position ID of multiple bond, and then parent chain. So parent chain should be 2,4. Not sure where some of the numbers came from, but that's okay. I wish he explained a little better on Google. This one I didn't get it right. It seems like the answer options are missing from your query. Oh, so hydrogen wasn't an organic molecule. Nice. How many valence electrons are present in butane? 26. I wonder if this is like a commenting or based on our chart. 26. So I guess this is a comment. This is just how much the total number of valence electrons butane has, 26. Same number, which is 26. Iron has 26, same as butane. Let's look up if Rukur emits any smell. Oh. Emit a sweet smell. Chemical properties of carboxylic acid. An ester is an organic compound that is derivative of carboxylic acid, in which hydrogen atom of hydroxyl group has been replaced with a alkyl group. Interesting. So it's not like AI where it kind of like answers your questions straightforward. What potion has a sweet smell? So I kind of want like a yes or no question because we got the answer here. I just wanted to like confirm it, learn more about it, but it is a little more difficult. But they are not bonded to any hydrogen atom. Okay. Use this information to answer the following 5 questions. This one was the London dispersion forces. So let's look up London dispersion forces on Google. We have a little AI overview of, this is Khan Academy, I think. Yeah, so the AI is providing Khan Academy, which is my go-to website, but for chemistry seems to be this LibreText, which is a lot of verbose. It's not too hard to see why dipole forces, London dispersion forces. I'm gonna read this real quick. So I remember in the quiz we also had the solid at room temperature. So it's over here, London dispersion. Can explain how liquids and solid forms in molecules with no parental dipole moment. Dispersion means the way things are distributed or spread out. Because the electrons move around a lot, sometimes they may move in a way that creates temporary dipole moment. I see. The more electrons atom has, the more easily this can happen, because they like to move around more often. You see? Okay. So that was a good website. Why can they mix with water? They both can participate in hydrogen bonding. Water is also able to do so, like dissolves likes. Most carbon atoms. Much higher than because of that. Yeah, so I was gonna say it could be he has the smallest boiling point, shortest boiling point. Use this following diagram. So a side chain. Let's look it up, see what we get. The overview, adding a methyl group. Let's go to our website. Is that what we wanted to know? I wanted to know about sidechain. Chemistry. Yeah, so sidechain should be the ones that can attach to the main chain. I see, that's why there's sidechain. Okay. So in this case, all additions produce the same molecule. Yeah, because once you add to this one, then it connects all around. If you add here, it'll connect all around. Interesting. So I guess the difference is times 10, so maybe each molecule has 10 valence electrons. What is the maximum number of? I got this one right. Delocalized. Okay, and I got this one right. Using NA will neutralize the solution. Cool. Let's do more study on Google. I have some prompts I wanted to ask. We can say, what are the IUPAC rule of naming the sidechain? So I feel like we just learned about this one. Come back to the same chemistry website. Hydro bonds having no double or triple bond functional groups are classified as alkane or cyclocanes. So we have isomer of 1, name is hexane. We have 1, so they're all thane. A and E, no, but we have 2 and 3. Not sure what the difference is. These are the rules, rule 1, rule 2. So choose the longest, most substituted carbon chain. Carbons bonded to a functional group must have the lowest possible carbon number. So 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8. That's how you count. Nice. Let's go to the next one. Organic functional groups significantly impact the molecule's physical properties like boiling point, melting point, and etc. Here is our website again. There's 2 versions of it. I think we want to know about organic functionals, not compounds. I wonder if they're the same thing. Not the most concise website, I would say. Let's try another one. Functional groups refer to a specific atom bonds bonded in a certain arrangement that give a compound certain physical and chemical properties. Wow, so this was a very concise, straightforward answer. We have key points and key terms. Functional group. class of compounds. Functionalization is an addition of specific functional groups to afford the compound new desirable properties. Nice. Yeah, so this is a much better website than the one I have been looking at. Let's go next one. Intermolecular force types. Intermolecular forces, or in short IMFs, are attractive forces between molecules, and they are generally weaker than intermolecular forces. London dispersion force, dipole force. So intermolecular forces are, so the ones we've been looking at are called the intermolecular forces. Let's see if we could learn more about them. I'm not a big fan of this website. Let's keep trying a different one. This one. Wow, so it's 8 pages, a little doc, PDF file. The term intermolecular forces is used to describe the forces of attraction between atoms, molecules, and ions. So we did learn about this. So this is a good website, kind of like the AI overview, but with more information. Positive and negative. Yeah, so types of, this was literally our question, types of intermolecular forces. So these three are the most common ones. This is what London dispersion looks like, and this is what dipole looks like. And this is hydrogen bonding, all connected to each other. Nice. Pretty good website, I would say. University of California. Few more things we should touch upon, like what are valence electrons of an element. Like we saw, one was at 26, I remember. In the outermost shell of an atom. I see. Let's go to a website. Let's see what Khan Academy says. An atom's valence electrons are the electrons in its outermost shell. So only in the outermost shell. And shown in red. So 2, 4, 6, 7. I guess the numbers are the same as the number of dots. That's the pattern I see. I'm not. Oh, increases going left to right. Yeah. Nice. Alright, I think we have one more thing to look at, which is called, what is titration? Titration is an analytical chemistry technique used to determine the concentration of a substance. I don't want to look at the AI overview too much. I want to find more nice websites, kind of like concise, clear websites, not so complicated. Titration. Titration is a slow addition of one solution of a known concentration called titrate. So I guess it's an addition of one solution of a known concentration. Slow addition. On Google we get some short videos as well. It's an analytical technique that allows the specific substance dissolved in a sample by addition of reagent to known concentration. Interesting. Cool. I wanna find another website, another university one. No, it's a technique where the solution of unknown solution. Okay, that was very straightforward, and it makes sense. So it's a technique used to determine an unknown substance or concentration. Now let's close this one and take a 5-minute break before we start our exam. Chemistry B. Okay, I'm gonna keep the break short so we can continue. Use this diagram to answer the following 7 questions. Wow, this one is a lot more complicated than the first one. There are how many carbon atoms in the parent chain? What is it called? So, if I remember the counting from Google study correctly, that's 1. Every edge is like a point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Minus 1, minus 2, 3, 4. 13 minus 4, it's 9. 9. Number of this molecule will be a carbon. Numbering of this same as the last one. You should start at 1. And let's see. Use this information along with previous diagram to answer the following 5 questions. Consider possible branches at carbon X, Y, and Z. X, Y, and Z. Okay. Carbon Y. Interesting, it goes everywhere. It should just be methyl, this one. Because it's reacting with all 3. Which carbon can only make 1 more bond? X and Y. I'm looking at the graph. I'm gonna say all of them. Z, because I was looking at the Z could make two bonds. Ooh. This is gonna be hard. I remember the first one was a number and the symbol. Excuse me. So, and I said it would be methyl, so it would be like 1 dash methyl, and then yeah, that's all I got. In addition to a methyl group carbon, which would add an extra side chain, which could make a side. That could be I think it's the B. This one. Can have 2 side chains. A and B. Next. Which of the following molecules is not a molecule? Not an organic molecule. Carbon dioxide is organic. Metamax, chrome 4. This just doesn't sound organic. Present in a methane, butane or methane. Butane was 26, I remember, but I'm not sure how many is in a methane. Maybe like 10. I remember 3 times 10 we had to do 30 on the last quiz. It wasn't from Google study, so Google doesn't get the credit. Which element has the same number of electrons as methane has valence electrons? Methane, so 10. Carbon, oxygen, I'm not sure which one has 10. Beryllium is most likely to taste sour. Well, I remember I studied scoor is a sweet, emits a sweet smell, but I'm not sure which one tastes sour. Probably this one. Can you answer to the previous question in hydrogen bonding? SCU in hydrogen with other molecules. Lowest boiling point I'm not sure which one. How many hydrogen atoms does an alkane with n carbon atoms have? Two times. Yeah, all the all the numbers that I've studied on Google are different. I don't memorize the other molecules. It's okay. Yeah, over here he had diethyl methylcyclopentane, which molecules can partake in dipole-dipole interaction. Dipole-dipole can, I think, all these top three can participate in the dipole-dipole. Assume each substance is a liquid at room temperature. Which of these molecules can mix with tetrafluorous? Tetrafluorate. Maybe this one, because it's has such a low boiling point. Why can't they boil? Because of chemical bonding. What was that word? Chemical bonding. Okay, two more. Despite that, methanic acid has much fewer carbon atoms, then its boiling point is much higher because it contains more and participates in more hydrogen bonding. No, has oxygen atom. Symmetrical and acid is not. Has oxygen atoms. Oxygen atoms increase boiling point. To place in this list. Propanol. Propanol. should be maybe just higher than, yeah, in between the top two. Let's go back. Which of the following molecule is not an organic molecule? Methoxide. Yeah. There are 9, and it is called nonane. Yeah, I couldn't find the UI pack name. Use this diagram to answer the following 4 questions. That's the diagram. I assume it just ends there, it's not on purpose. The addition of methyl group to which carbon would not produce a molecule with a side chain? That would be this one. And it would not be a side chain if it exists here. The addition of methyl to which carbon would produce the same molecule? A and B may be the same, but so I think the additional carbon would produce the same molecule. All of them, I think, should produce the same molecule. Like if it goes here, it's identical. If it goes here, then it's identical. How many valence electrons are present in this molecule? So we learned about this one. It was 3 times 10, so 30. And what is the maximum number of propyl group that can be added to carbon A? It should be 1. Because, I mean, this is the only spot that can be added on. Let's go next. The electrons in a benzene molecule are not fixed on one atom. They are not sure. has been discovered. In the lab, you are presented with 5 vials that may contain the compound. How will you attempt to detect its presence? The orange dye, water, I remember the NaO8 will neutralize the solution. I remember this one from Chemistry A exam. Not sure. Are not fixed on one atom, what they're called. But I'm confident on this one that NaOH will neutralize the solution. Submit. View score. Yeah, so first one was right. Yeah, honestly, I would say the Google study on chemistry did not help too much. The one website provided, the chemistry website, it was verbose, hard to see the point, not concise at all. The charts provided were confusing. I happened to use Khan Academy once, and that website was a lot more helpful. Yeah, but overall, I don't think Google study helped too much in terms of going from chemistry A to chemistry B exam. I did not learn too much on Google. Going over going over chemistry A was a lot more helpful than some of the websites on the internet. Yeah, I highly recommend Khan Academy. It is a great source, and I don't know why on a lot of the questions I looked up, Khan Academy wasn't like a top website for it. I guess it's not as specific for chemistry. Thank you.